Hey guys, for today's video, we are going to discuss about the substitution rule. The substitution rule is a pretty common strategy to solve the integral problems. In fact, you will use this often to solve integral problems easily. Thing to do to let you understand what this formula means is to give an example. So I have here an example. What if I have f of x is equal to x plus 1? Now we let, because this is a substitution rule, so we let u equals to x plus 1, and our du would be dx. Now, because our u is x plus 1, we know that our x is equal to u minus 1. X is derived from this solution here. So we need to substitute because our topic for today is substitution rule. Now we need to substitute u and x as this. So what we have is the integral of u minus 1. Yes, we have u minus 1 now because x stands for u minus 1 times the square root of u du. Now, do not forget to write du because it is a variable in the expression, and du in fact has a value in this problem. That's why du, dx, dy, dt, d theta is very important to include in the problem. Otherwise, you will be marked wrong by your teacher. So this is pretty we distribute square root of u to this one. So we have, what is this? U is raised to 1, and then this is u raised to 1/2. So we have u raised to 3/2. Am I right? Minus u raised to 1/2. Am I right? So that would be, what could that be? U plus, of course, our common denominator here would be 2. So we need to add 2 at the top. So that means we have u raised to 5 over 2. Oops, that looks like 3 now, huh? Oops. U raised to 5 over 2 over, yes, 5 over 2, you guessed it right, minus, what do we have here? Our common denominator would be 2. What could be our numerator since we added 2? So that is 3 over 3/2 plus some constant c. Now remember, we're not done yet. We need to get rid of this. This is, if you ask me, that is a pretty ugly looking solution there. So we need to divide 1 by this. So if you divide 1 by that means it's just 2 over 5 u 5/2 minus 2/3 u 3/2 plus some constant c. Now we need to substitute back the original form. That means u is equal to x plus 1. So we need to get rid of u. We need to substitute back the x, the original formula. So that would be 2 over 5 x plus 1, 5 over 2 minus 2 over 3 x plus 1, 3/2 plus some constancy. Now this is what? This is the final answer. d theta over cosine squared theta. Oops, I meant to say times the square root of 1 plus tan theta. Now, what could be our u here? Now, our u is, of course, what's inside here, because in that way we can remove cosine squared theta here. So let u is equal to 1 plus tan theta. Du would be, what is the derivative of 1 plus tan theta? If you recall, the Pythagorean identity is 1 plus tan theta is equal to secant squared theta. Am I right? Secant squared theta, d theta. So d theta is equal to du over secant squared theta. We have here du secant squared theta cosine squared theta times square root of u. Now that is square root of u. Now we notice that secant squared theta and cosine squared is pretty similar, so we can remove this one. We are left with 1 square root of u du. Now 1 square root of u is equal to, we will rewrite this one, we will do it step by step. Right, as negative 1/2 du. Alright, 1/2 du. So negative 1/2 plus 1/2. Remember, we will apply power rule now. Remember, we will apply power rule. I don't know if you could read this one, but remember, apply power rule. Remember the power rule. Now we will apply power rule in this one. Now negative 1/2 plus 1, that would be 1/2. So u raised to 1/2 over, what could that be? 1/2 du. That means our final answer, we divide 1 by 1/2, we are remain with 2 u 1/2 plus some constant c. Now 2u 1/2 is almost, we are almost there. Now we need to substitute back. What is u? Remember, what is u? Our u is 1 plus tan theta. So we have here 2. We can use this or we can use that, but let's just use this to make our solution more clean. Plus c. Now this is our final answer. We have, what if I have secant cube x tangent x dx. How do we solve this problem? Well, the first thing is to rewrite this problem we need to expand this problem. And if you're having a hard time following this lesson, just review some of your notes from your integral calculus and read your book. So we let u we let u is equal to secant x. Now our du, this is our goal, to remove this one. Our du would be, of course, the derivative of secant is secant x, tangent x, dx. So we are left with u squared secant x tangent x times du over secant x tangent x. Cancel one out, so we are left with the integral of u squared du. Now that we will use the power rule for this one, that will be equal to u to the third over 3 plus some constancy, or substitute back what is u. U is secant, so we have secant cube x plus some constancy. Now okay, plus some constancy. Now this is our final answer.